So what do you mean by equilibrium? I told you, beta, a particle is in equilibrium. That means the particle will be having no acceleration in an inertial frame of your reference. And if the total external force acting on it is how much for me? Zero. Isn't it? Then the body is said to be in equilibrium. For an extended bodies, like say a rigid body like cone or maybe a solid sphere, body to be in equilibrium, there are two conditions to be satisfied, beta. The first condition is the center of mass of a body should be in equilibrium, and if total external force acting on it must be equal to zero. So sum of your all external forces must be equal to zero for the translational equilibrium. In the same way, the body remains in equilibrium if the total external torque acting on the body is zero for rotational condition. So summation of all the torque must be equal to zero about any point. That is, this is called as of your rotational equilibrium. This point is called as of what? Rotational equilibrium. For translational equilibrium, sum of the net forces must be equal to zero. For rotational equilibrium, sum of total torque acting on the system must be equal to zero. In the same way, see, when a rigid body is at rest means there is no translation and no rotation. Like a table, isn't it? Like a table, which is always at a rest. So there is no translation, no rotation. So such type of equilibrium is called as what? Static equilibrium. So in static equilibrium, some of the forces will be zero, some of the torque acting on the system is also equal to zero. Now, if rigid body is in uniform translational motion, so when I'm using uniform translation motion without any rotation, such body is said to be in general equilibrium. Even in that condition, some of the forces must be equal to zero, some of your torques must be also be equal to zero part of relation. Okay.
Yes.
Now, if the forces are lying in XY plane for equilibrium, sum of all the x-axis forces must be zero, y-axis must be zero, z-axis to be zero part of relation. Okay. Now, this is a sign convention where we are using data to solve the problems for a body to be in equilibrium. Leftward force must be equal to rightward force. Upward force balance your downward force, and the clockwise force torques must be equal to your anti-clockwise torques. Okay.
Yes, sir.
And also, I told you one more thing: hinge. If any force is acting on the hinge part of relation and it is passing through the axis, then torque due to the hinge will be zero and torque due to roller will be equal to zero. If hinge is making an angle reaction, if it is making an angle theta, so you just resolve that one into your x-axis and as well as of your y-axis, like rx and ry, and try to simplify for the given condition. Okay, na?
Yes, sir.
Okay, take one small problem on this one, beta. Say for example, I got a uniform rod. Record అవుతుంది కదా? Uniform rod of mass m, and length L, and length capital L is suspended through two vertical strings. Through two vertical strings of equal lengths. Fixed at ends. Stop. Small object of mass 2m is placed at a distance L by 4 from the left end. Find tension in the two strings. Find tension in the two strings. So first try to understand the question better. See the question what exactly I am giving you for the given condition. So we got an uniform rod of mass how much m, and length is given as of your L. is suspended through the two vertical strings. Is suspended through the two vertical strings. And the situation is something like this. Okay.
Yes.
From here it is hanging here. This one. And here also it is hanging like this. Okay. Both of them are supported like this. Okay. So uniform rod of mass, how much per meter? Mass is given as of here equal to your M. Length of this one is equals to your L. Length of this one is equals to your L. Okay. Is suspended through two vertical strings. The two vertical strings of equal length.
Yes.
At the ends. They have been fixed at the ends. This has been fixed to the ceiling. A small object of mass of your 2m is being placed at a distance of L by 4 from the left end. ఇది left end కదా, ఇది A అనుకుందాం, ఇది B అనుకుందాం.
Yes, sir.
Okay, ఇది దీని సెంటర్ కదా, దీని సెంటర్ కాబట్టి weight of this body is acting in the downward direction. This is your m into g. Now we are keeping a mass of your 2m somewhere ఇక్కడ అనుకుందాం. Okay, the distance from here to here, this distance is how much for me? L by 4.
4.
Okay, weight of this body here
Yes.
acting is right now 2 mg in the downward direction. So tension developed in the
Yes, sir.
string here. Here it is T, and here it is also T. So obviously this is also T, and this is also your T part of relation. So A to B,
Yes.
this is a mass, and this length will be equal to L by 2. Okay. Now rod is in equilibrium or
Yes,
not?
sir.
As rod is in equilibrium. As rod is in equilibrium. What is the condition? Sum of all the forces. ఇది y లో ఉంది కాదు, y axis must be equal
Yes,
to
sir.
0. ఎందుకంటే వర్టికల్ ఫోర్సెస్, హారిజాంటల్ ఏమీ లేవు, ఓన్లీ వర్టికల్
Yes,
ఫోర్సెస్
sir.
లో ఏమేమి ఉన్నాయి కూడా ఇక్కడ, వన్ టెన్షన్ ఇన్ అప్వర్డ్ డైరెక్షన్. సో టూ డిఫరెంట్ స్ట్రింగ్స్ కాబట్టి
It is
ఇది నేను
balanced.
T2 తీసుకుంటాను. దిస్ విల్ బి టేకింగ్ as T2. This one is a T1 and this one is also T2. Okay, this T1 T2 are acting in the upward direction. So this one is a T1 plus of your T2 must be equal to this 2mg plus of your mg. అంతే కదా, this T1 and T2 both of them in upward direction.
Yes, sir.
These two forces must balance this 2mg and mg. Antena, that
Yes,
means
sir.
T1
Yes, sir.
plus of your T2 must be equal to how much for me? 3 times of your mg.
3
This is
mg.
my equation number 1. The same way,
Yes, sir.
torque about point A must be equal to 0. Torque about A must be 0. అంతే కదా, for rotational equilibrium. So torque about
Yes, sir.
point A must be equal to 0. Now what are the torques acting? Ichudu, this force into this perpendicular distance, ikkada force unda L2.
Yes,
This
sir.
L2 is in upward direction,
Sir,
and here
L2
this
is
one is nothing but a
distance.
figure. Yeah, this distance is how much? L,
Yes, sir.
isn't it? The same way mg, and this distance is
Yes,
L
sir.
by 2. 2mg
Yes.
and L by 4. These
Yes,
two are
sir.
acting in the same direction. Let's see, if this is a torque, I'll draw here. This is the point A. Ikkada torque undi ikkada. So this torque is what? T2. T2 into your L. In which direction it is moving? Anti-clockwise.
Yes, sir.
So this distance is nothing but equal to your L. This is your anti-clockwise. And there is one more force acting on this one. What is that force? mg in the downward direction.
mg.
So this one is your mg, and this distance is how much for me? L by 2. So mg into L by 2, it is moving in this direction, beta, clockwise. This is
Clockwise,
an
yes, sir.
anti-clockwise. And one more force is acting on this one. This is equal to your how much?
2 mg.
2 mg. This distance is how much? L by 4.
L by
This is
4.
also moving in this direction, clockwise.
Clockwise.
Isn't it? So these two clockwise are in
Yes,
the
sir.
same direction. This is in opposite direction. So these two torques must be, this upper torque must be balancing this torque kada. So I can write
Yes, sir.
here T2 into your L must be equal to your, this must be equal to your 2 mg into your L by 4 plus of your mg into your L by 2. Ante kada. These two torques are acting in the same
Yes, sir.
direction. This will add up and that will be equal to this torque. So in this one right now, if I'm writing the relation, this one is 2 ones, this one is 2 twos. So this one is T2 into your L is equals to idantha idi mg into your L by 2 plus mg into your L by 2. How much it will be? Mg
Yes, sir.
ana kada, mg into your L. This will get cancelled. So T2 will be equal to how much beta? Mg. Antena? If T2 is
Yes,
your
sir.
mg from
Got it, got it.
equation 1, yeah, from equation 1, we can write T1 plus T2 is your mg is equals to your, here this one is 3 mg. So T1 will be equal to how much beta? This will go here negative. So that will become for me 2 times of your mg. Antena? So we got the
Yes,
values
sir.
of T1 and as well as of your T2 part of relation.
T2.
I hope you got a rough idea how to do the problems related to your torque conditions.
Yes, sir.
ఓకేనా? వీకెండ్ సిలబస్ ఎక్కడి వరకు ఉంది? మొత్తం రొటేషనల్ టార్క్ ఉంది కదా?
Yes, sir. మొత్తం టార్క్ ఉంది సార్. దీని
ముందే
తర్వాత
ఫినిష్ స్టార్ట్
మూమెంట్ ఆఫ్
చేశారా?
ఇనర్షియా ఇంకా స్టార్ట్ చేయలేదు సార్. ఈక్విలిబ్రియంలోనే కొన్ని క్వశ్చన్స్ చేసాం సార్. అల్మారా టైప్ అది, మళ్ళీ స్పియర్ మూవింగ్ అప్ ది స్టేర్.
స్పియర్ మూవింగ్
అప్ ది స్టేర్స్ సార్.
స్పియర్ మూవింగ్ అప్ ద స్టేర్స్.
Sir, it is there up till brief idea of about theorems, sir.
ఏనా?
It is the portions there up till brief idea about theorems and MI of regular bodies, expressions only.
ఓకే, చలో. See this question better. Two men P and Q, P and Q are carrying a uniform rod, of length capital L on their shoulders. First of all, the rod is held horizontally. The rod is held horizontally such that P gets 1/3 load. First of all, if P is at one end, of the rod, the distance of Q from that end is dash. Give the options. This one is L by 3. Next one is 2L by 3. Third one is 3L by 4. And fourth one is capital L. Right, Shinana sir? So try to draw the diagram as per your understanding for this.
Yes.
So we got two men P and Q who are carrying a uniform rod of length of your L. Okay, so if I draw the wire for this one, yeah, this is your rod.
P
Okay,
and Q. Yes, sir.
and persons, one person on the shoulder, he is exerting a force of how much? W by 3. Other end of this one
Yes, sir.
is exerting a force of your how much? 2W by 3. So
Yes, sir.
if this is one end P, this is your another end a Q, and distance between them is say for example X. And the other two men P and Q are carrying a uniform rod of length capital L on their shoulders. The rod is held horizontally such that P gets 1/3 of your load. And here it will be equal to 1/3 of your load. Load is nothing but W. Total weight of the load
Yes, sir.
will be acting in the downward direction. That will be equal to W.
Mm.
W is equals to mg. If this is getting
Yes, sir.
W by 3,
Load.
so this
Yes.
fellow will get a 2W by over 3. అంతే కదా?
Yes, sir. Yes, sir.
So this is at one end. This is at your one end kabatti. This distance will be equal to how much for me, or L by 2. And from here to here, this distance I don't know between P and Q. Total length of the rod is L, but P and Q are not exactly at the both the ends. Because if they are at the both the ends means both of them will get the same amount of load. అంతే కదా?
Yes, sir.
Rod ఎంత ముందర ఉంటే మాత్రమే load will be the different right now. For rotational
Different. Yes,
equilibrium,
sir.
talk about the point me must be equal to how much for me? For equilibrium, net torque about the point P must be equal to 0. So about point P ante this weight is acting. So this W into L by 2. This is one torque acting on this one. So W into L by 2. In this direction, beta. In this direction. Another.
Yes, sir.
Torque because of W by 3. How much it will be? 0. Because it is passing through the point P itself. Ante kada?
Yes, sir.
So torque
Yes,
due
sir.
to W by 3 is equals to 0 because the torque has
0.
been passing through the point P itself. Then torque due to the point Q towards the point P. Until this is moving in this direction. Idemo arrow mark downward. This one
Anti-clockwise.
is in the clockwise. This will be your
Clockwise.
anti-clockwise. So clockwise torque
Anti-clockwise.
equal to anti-clockwise torque. That means this will be equal to 2W by 3 into your X. So this W will get cancelled. So X will be equal to how much beta? 3 into your
PL
L
by 2.
divided by your 4.
4. Yes, sir.
Clear? So third option must be the
Yes,
answer
sir.
first. Clear?
Yes, sir.
I'll give you one more
Sir,
question.
one second. Sir, one second.
Directions of the torques you make clear beta. This one is in the
Yes, sir.
clockwise and this is anti-clockwise. Only two kabatti
Yes, sir. That.
must be equal to anti-clockwise torque.
Yes, sir.
Okay. Anti-clockwise will
Thank
take
you, sir.
positive
Yes,
and
sir.
clockwise will be taking negative. Okay, na?
Negative. Yes. Yes, sir.
Okay. Go question చూడండి. We got a uniform horizontal, a uniform, a uniform horizontal meter scale, horizontal meter scale of mass m, of mass m is suspended by two vertical strings, attached to its two ends, First of a block of mass 3m, 3m is placed on the 60 centimeter mark, The tension in the two strings, two strings are in the ratio. First option is 17:19. Second one is 19:21. Third one is 17:23. And fourth one is 19:23. Okay. So we got an uniform horizontal meter scale. Meter scale means what will be the distance beta? 100 centimeters. Ante kada?
Yes, sir.
Meters
Yes, sir.
100 centimeters. Of mass and the m is
Centimeters.
suspended by two vertical strings attached to its two ends. In the first problem చేసినట్లే. So we are having a meter scale like this. Okay. And they are been attached by the strings. Like this. Okay. Now forces acting on this body
Yes.
is weight of this body acts in the downward direction. So two
Yes, sir.
vertical strings attached to the two ends. A block of mass 3m is being placed at 60 centimeters. అంటే ఇది ఇక్కడ నుంచి ఇక్కడ వరకు ఇదంతా 50 సెంటీమీటర్స్ అంతేనా సెంటర్ కాడ
Yes, sir. So little bit.
దీని సెంటర్ బాడీ బట్టి దీని మాస్ వచ్చేసి m into g. దీని మాస్ వచ్చేసి
Yes,
m
sir.
into g. Now we are keeping a mass of your how much? We are keeping a mass of your 3m. This means somewhere here. This is your 3m. That means weight of this one will become for me 3m into your g. So this distance will become how much for me? 60 centimeters.
60 centimeters. Yes, sir.
Okay. So a block of mass 3m is being placed on 60 centimeter mark. The tension in the two strings are how much? Now see, tension in this one will be equal to T1 and tension in this one will be equal to T2.
T2.
Now talk about vertical forces. And then the 3 mg and mg downward, T1 plus T2 in the upward direction. So I can write
Upward
here
direction. Yes.
T1 plus of your T2 must be equal to your mg plus of your 3 into your mg. That means first vertical forces must be balanced here. So T1 plus T2 will be equal to 4 times of your mg. This is my equation number 1. Okay. So
Yes, sir.
this is your
Yes, sir.
point A and this one is your point B. If I'm taking about the torque, tension due to the T1 and about point A. T1 is passing through the point A, but if A is your reference,
It's
torque
zero,
due
sir.
to the T1 will become 0. Very good. Total
Yes, sir.
torque about point A must be equal to 0. And this will be
Zero.
your
Yes.
mg into your 50. ante kada mg into your 50 in which
Yes, sir.
direction beta? Clockwise. 3mg into
Clockwise.
this one is also in the
Indicator.
clockwise. So round same direction act అవుతాయి
Clockwise.
కాబట్టి. So this one is your 3mg into your 60. That must be equal to your. Here it is T2 into this one is 100 centimeters. Tension torque due to the tension T1 will be equal to how much better? Torque due to T1 is equals to 0 because T1 is passing through the point A. T2 is at a distance of your 100 centimeters. So torque due to your T2 will be equal to your how much better? T2 into distance of that one is your 100 centimeters. Antena?
Yes, sir.
So this is how much better? 50 mg. This one is your 50 times of your mg. This one is of your how much for me?
180.
180
180.
mg. 180 mg is equals to 100 times of your T2.
100 T2.
So ఇదెంత అవుతుందండి?
Yes, sir.
180 plus 50 ఎంత?
230. 230 mg.
230
30, sir.
mg. That is equals to 100 T2. E0 వెళ్ళిపోతుంది. So T2 will be
Yes.
equal to how much better? 2.3 mg.
Yes, sir.
ఈ 10 ఇక్కడ కిందకి వచ్చేస్తుంది కదా. 23 divided by
Yes,
10
sir.
is
And
2.3 times
10,
of your mg.
2.3.
Yeah. So from T1 plus T2, we know that from T1 plus T2 is equal to how much for me? 4 times of your mg. So it is a T1 plus this one is a 2.3 times of your mg is equals to 4 times of your mg. So T1 will be equal to how much better? 4 minus 2.3.
1.7.
1.7. 1.7 times of your mg. So T1 by T2 is how much? T1 by T2 is equals to T1 by T2 will be equal to how much it is? 2 point. So this one is how much? 1 point kada T1. So it is
1.7 divided
2.7 mg divided
mg
by what?
divided
2.3 mg.
2.3
mg gets
mg
cancelled.
mg.
So this will come out for me 17 by 23. Isn't it?
Yes, sir.
So 17 is to 23 will be the answer for this question. So I
Yes,
hope
sir.
you got something related to this one, beta.
Yes, sir.
Isn't it? So that are the conditions. How
Yes,
do
sir.
we calculate the given conditions part of relations? Okay. ఇంకో ప్రాబ్లం చేస్తాం.
Yes, sir. Yes.
See this question, beta. So we got, say for example, two men support a uniform horizontal beam, at its two ends, your two ends. If one of them suddenly lets go, అంటే suddenly support ని తీసేస్తున్నాడు. So
Yes,
the
sir.
exerted by the beam, on the other man will, number one, remains unaffected. Number two, increase. Number three, decrease. Number four, become unequal to the force exerted by him on the beam. Chalo, try to see it. What answer can you give me? So we got
Yes.
two men who have been supporting a uniform horizontal beam, same like a previous case beta. I need to draw a beam right now. So this one is like, say for example, a beam. On this one we are exerting the force. The two men supports a uniform horizontal beam at its two ends. If one of them is suddenly let go, ante one fellow is exerting the force on this one like this, and another fellow is also exerting the force support on this one like this. And weight of this person is acting in which direction beta? E block your weight is acting in the downward direction. So weight of this one is acting in the downward direction. Okay. So this will be
Yes, sir.
equal to your W. This one is one reaction and this is your another reaction. Okay. So what will be the R beta? R will be supporting how much amount of weight beta? W by 2 kada. R will be
Yes, sir.
equal to how much? R is nothing but reaction, that will be equal to W by 2. Ante kada? This is half
Yes, sir.
part of the length right now. So this distance is right now for me or how much? L. Now see, this is the initial condition, isn't it? So when support is been removed, then what happens? When support is been removed from this rod, I'm writing it roughly here, see. ఒక end support తీసేసాడు అనుకో, అప్పుడు ఏమైపోతుంది? The weight of the body will be acting in the downward direction and this will start rotating. ఒక సడన్ గా ఇట్లా వచ్చేస్తే ఏమైపోతుంది? కింద పడుతుంది. దీనిపైన రియాక్షన్ ఏమైపోతుంది? చేంజ్ అయిపోతుంది. దట్ వన్ ఐ డోంట్ నో, దట్ ఐఎమ్ టేకింగ్ as R dash. అంతే కదా? ఇప్పుడు సపోర్ట్ సడన్ గా సపోర్ట్
Yes, sir.
తీసేసాడు అనుకో, ఏమైపోతుంది? ఇది కింద పడుతుంది. కానీ మొత్తం కింద పడదు,
Yes,
ఇది
sir.
రొటేట్, ఎందుకని దిస్ ఫెలో స్టిల్ హోల్డింగ్ కాబట్టి. సో ఇట్ విల్ బి రొటేటింగ్ విత్ ఇన్ యాంగులర్ యాక్సిలరేషన్ యాజ్ ఇట్ ఈస్ సర్క్యులర్ పాత్ కాబట్టి విత్ ఆల్ఫా. And also it is
Yes,
falling in
sir.
the downward direction with an acceleration E. ఇక్కడ నుంచి ఇక్కడ వరకు ఈ డిస్టెన్స్ ఎంత అవుతుంది? L/2. Now write the equation for this one beta. So W is acting in the downward direction minus R dash is acting in the upward direction. That will be equal to your how much for me? W into your A, G by your A. అంతే కదా? W is equals to M into G. So mass is equals to what for me? W by G కదా?
Yes, sir.
Isn't it? So W minus R dash is equals to W into your A part. అంటే W into, now this is a weight condition, vertical ga forces ni. Now torque, if I am writing torque about O అనుకుందాం, about O, ఇదెంత అవుతుంది? W into L/2. W into your L/2 must be equal to, this weight must balance the remaining weight of your body part of relation. Adent undi, when you remove the mass of the body, the remaining part of the body which is been hanging in the downward direction will be equal to your how much for the given condition. Enta avutundi cheppo sir? This will be equal to angular acceleration enta nana? A is equals to your R into your alpha. R is nothing but here L,
Yes,
isn't it?
L.
R is equals to enta avutundi cheppu? So R is nothing but about the center of mass if it is hanging right now for me. So that will be equal to your how much for me? So R dash will be equal to your W by G into your W. ఎంత అవుతుంది చెప్పు? This must be equal to how much beta? I into alpha kada? Tau is equals to your I into alpha. I is nothing but how much for me?
Okay,
Moment of
yes,
inertia
sir.
of the rod. Moment of inertia of the rod is nothing but of your M dash into, this one is L square divided by 3 into your alpha. ఇది నీకు తెలియదు ఇంకా. So just right now remember, moment of
Yes,
inertia of a
sir.
rod passing through the center will be equal to ml square by 3. Removed mass M dash కాబట్టి M dash రాస్తున్నాను. M dash will be equal to how much beta? W by your G into your L square divided by your 3 into your alpha. So this one is W into your L by 2. Anything is getting cancelled in this one, you see? This L and ఇక్కడ నుంచి ఒక స్క్వేర్ ఒకటి వెళ్ళిపోతే ఇక్కడ స్క్వేర్ అయిపోతుంది. This W will also get cancelled. So alpha
Yes,
is
sir.
equals to how much? So alpha is equals to, this 3G will go up right now here. So it is a 3G divided by L square and 2 will come here. So it is a 2 into your L square. అంతేనా?
Yes, sir.
ఇది L square ఏనా? సారీ, ఇది L square. ఈ L ఇది వెళ్ళిపోతే
Will become
దీని
L.
నుంచి ఒకటే మిగులుతుంది. సో ఇట్ ఈస్ నథింగ్ బట్ 2 into your L. Moment of
L.
inertia is ఇక్కడ
Yes.
ml square రాశాను కదా. సో దిస్ వన్ is m dash into m into your L square. ఇది స్క్వేర్, ఇది L. ఈ L ఈ స్క్వేర్ వెళ్ళిపోతే here it will be remaining 1. So alpha is equals to 3G by your 2 into your L. So this will be the angular acceleration. So what will be the linear acceleration? We know the formula. A is equals to your R into your alpha. R will be equal to L by 2 into alpha is equals to 3G by 2 into your L. This L gets cancelled. So it is your 3G divided by your 4. Isn't it? So this is your A value.
Yes,
So I
sir.
got the value of your A. That value you can substitute here. So I'll be getting the R dash value. So from this equation. Okay. This I take it as of your equation 1. From equation 1, I can write W minus R dash is equals to W by G into A. A is how much for me? 3G by your 4. EG వెళ్ళిపోతుంది కాబట్టి, so this will be W minus of your R dash is equals to, ఇదంతా అవుతుందన్న 3W by your 4. అంతేనా? So this one
Yes,
is
sir.
3W divided by 4. R dash ఎంత అవుతుంది అప్పుడు? R dash is equals to 3 by 4. This will become for me minus కాబట్టి, so this will go positive, ఇది అయితే నెగటివ్ అయిపోతుంది. ఇది తీసేయాలంటే 3 by 4 minus this one, అంటే this will become for me how much? W by 4. అంతే కదా?
Yes, sir.
So R dash is 3W by 4. యాక్చువల్లీ R ఎంత ఉంది? W by 2 ఉంది. వాళ్ళు ఇద్దరు సపోర్ట్ చేసేటప్పుడు ఎంత ఉంది? W by 2 ఉంది.
W by
సపోర్ట్
2. Yes,
తీసేసిన
sir.
తర్వాత ఎంత వచ్చింది? W by 4 ఉంది.
W by 4.
R dash is lesser than of your R. So what is the option you can write for this one right now? Isn't it? The force exerted by the beam. This is the force exerted by the beam R, and ఇక్కడ వచ్చేసి R dash. So increase in the decrease in the. So it will be decreasing. So third option must be the
Decreasing.
answer.
Yes, sir. Because from
Clear?
W by 2, it's come to W by 4.
Yeah.
Yes, sir.
Got it?
Yes, sir.
So that is the way how do we get the questions related to your torque conditions part of relations. I hope you got an idea related to that one, isn't it?
Yes, sir.
I'll give you one question for homework beta. You try to do it out and let me know. Time in the mandar inka?
Okay.
Time on
Inka
the
3 minutes.
okay, sure.
3 minutes is there.
Yes, sir. A question I am trying to give you very good question. A uniform rod of mass capital M and length capital L rest on two supports. Rest on your two supports. A ball of mass M is equals to capital M by 3. Small m is equals to capital M by 3 is placed at a distance L by 8 from the center. L by 8 from the center as shown. First of all, find reactions at support. Find the reaction at your supports. So this is the rod given for me. Okay, and one force is here which is been acting. This is your A, and this is your another force that is nothing but of your B. Didi dini yoka center. Okay, and on this one we are keeping a ball somewhere here right now of mass of your how much M. This is at this distance. And from here
Yes.
to here, this distance is L by 4. This point of support, whatever you are applying, this distance is nothing but at your L by 4, point B. Okay. And this A is also
Yes,
exerting
sir.
the force at the distance of your L by 4. Okay. And the distance from this
Yes,
center
sir.
to this mass, this distance is given in the problem as of your L by 8.
L by
అంతే కదా,
8.
బాల్ ఆఫ్ మాస్ M by 3 is
Yes, sir.
being
L by
considered
8.
L by 8 from the center. ఇది సెంటర్. ఈ సెంటర్ నుంచి ఈ
Yes,
డిస్టెన్స్
sir.
వచ్చేసి మనకు L by 8. మనకు ఇంకా ఈ గ్యాప్
Yes, sir.
ఉండిపోయింది ఇక్కడ, ఇజంట్ ఇట్, ఈ గ్యాప్ ఉండిపోయింది. ఈ డిస్టెన్స్
Yes,
ఎంత
sir.
ఉంది ఇక్కడ L by 4. ఇక్కడ నుంచి ఇక్కడ వరకు
Yes,
సెంటర్
sir.
నుంచి డిస్టెన్స్ ఎంత మొత్తము L by 2.
L by 2.
This one will become for me L by 2, and this distance is also your L by 2. Center నుంచి ఈ distance is also your
I'll
L by
try
2.
this, sir.
This is the situation given for us. So we need to calculate what the reaction at your supports will be equal to your how much. What is the reaction supports at your part of relation? అంటే reaction supports అంటే R
Yes.
ఇట్లే పెట్టుకోవాలి. So you need to write this R and R like this. This
Okay.
R and reaction
Yes, sir.
పెట్టుకొని. So at point R you take reaction. That is nothing but of your reaction at this one is at RA, and this one is your due to this one. This one is your reaction of your RB. So RA is how much and RB
Yes,
is
sir.
how much. Thinking okay, na? So
Okay,
try
sir.
to do it
Yes,
out
sir.
with the
I'll
help
try
of
this,
your
sir.
talk on your own, and let